So in this session, we're gonna start chapter 6. Uh, it's about branching. Uh, so branching, which is how your program makes decisions, uh, we'll keep we'll keep it simple and practical. First, we have if else branches. So an if else is just a program is the program asking a yes or no question and choosing a path. uh, the basic flow would be like if condition do this, else if another condition do that, else do the default. So uh, like think of a grading example. So if the score is 60 or higher, that's a pass, otherwise it's a fail. One conditions, two different outcomes. uh, there are two quick style notes that saves headaches. Use braces. uh, Even for one line bodies, it keeps the code readable and prevents bugs when you add more later. And the keep the chain shallow. If you feel yourself making a pyramid of if inside if, consider an else if chain or a helper method. It's a good idea. uh, so let's discuss a simple example where you have a input. Let's call it number score. And if score is greater than or equal to 60, print pass, else print try again, and then extend it like greater than or equal to 90a, greater than or equal to 80b, 70c, 60d, else f. So that's a good example to start with. I recommend to try that example when you get time. But some of the things to keep in mind is missing braces. Like for example, if x greater than 0, uh, print ln. Uh, um, let's say okay, uh, and then uh, so let me just copy this. Print ln done. Uh, Only the first line is controlled, which is easy to read, easy to misread, sorry. And when it comes to deeper ladders, like if like first five nested ifs are hard to read, so prefer else if chains or break logic into smaller methods. So when do you when do you use else if or second if? Is use else if when conditions are mutually exclusive and you want exactly one branch to run to run. Use a separate if when both can run independently. So that's about the basic idea. uh, Actually, yeah. So and another thing is detecting equal values with branches. uh, so let's talk about equality, because Java treats numbers and objects differently. So for primitives like int, boolean, double, use uh, compare equals. uh, to check uh, equality. Like for example, if a compare equals b, print something. So and objects, for objects like string, do not use compare equals to compare content. Compare equals checks if they're the same object in memory, not the same text. So to compare what's inside, use dot equals. uh, so like for primitives, let's take an example for primitives. Let's say int a is equal to 5, int b is equal to 5 again, and a compare equals, actually, so let's say int a is equals to 5, and int b equals 5. Now I'm just gonna write the pseudocode b. This is this will be true because the same numeric value, but let's say uh, string string s1 equals hello, and let's say string um, s2 equals, uh, let's say, actually let's say new string, uh, so now s1 compare equals, this might be false uh, because different objects, but s1 dot s1 dot equals uh, s2 in brackets braces is true, same content. uh, the bonus, another thing is you can use equals ignore case for case insensitive checks. So yeah, that's a small example from for primitives and strings objects. So when do you branch on equality? Numbers, like checking exact matches, for example, uh, yeah, lives is equal to compare equals 0. That's when you say game over. So strings is checking commands like input equals quit, usernames or menu choices. Always prefer dot equals for strings. And some other things to keep in mind is using compare equals for strings. So it can silently fail because two separate string objects with the same letter are not the same object. And another thing is floating point equality. So we'll cover this later, but be careful. Decimals aren't always exact. For now, stick with integers, strings for equality. So how do you compare two strings for content? Use dot equals or dot equals ignore case, uh, if case if case doesn't matter. But yeah, so if else is about choosing one path based on a condition. Use braces and keep logic readable. Use compare equals for primitives. Use dot equals for strings and other objects. If conditions are mutually exclusive, use a else if chain, so only one branch runs. Uh, so after the session, try small experiments like in your IDE, or you also use iBooks. But like for example, build the pass letter grade chain and test the edges like 29, 60, 89. And another example you could try is compare two integers and two strings. Use compare equals and dot equals and print the results and see how it works. And other thing you could also try is add an independent check with a second if, like for example, if score less than 60, print retake it eligible to feel the difference between else if and separate if. So yeah, those are the good examples to start with. So next topic is detecting ranges with branches. So we're gonna make our if statements a little smarter for checking ranges, not just single equals. So this is how you write things like grade branch, BMI categories, or speed limits. Uh, the first the tools are less than equals to greater than or equal to. Uh, so less than and greater than are exclusive, not including the boundary. Less than equals greater than equals are inclusive, including the boundary. So let's do a simple grade bands example. Suppose A is let's actually take an example. So A is when it's greater than or equal to 90, and B is uh, 80 to uh, 89. C is 70 to 79. D is uh, 60 to 69. And if it's less than 60, that's an F. So if I ask where does 90 fall if A is greater than or equal to 90, uh, obviously the answer is A, because greater than or equals to equals includes 90. So something to watch out here is off by one at the edges. If you write like if score greater than 90 instead of greater than or equal to 90, you just excluded 90 by accident, and double check boundaries and be clear whether the edge should be in or out. uh, do a mental test around every boundary, like 59, 60, 69, 70. If any of those feel wrong, fix your operator. uh, yeah, it's simple example. But next is detecting ranges with branches. Uh, yeah, so we're gonna continue with that. uh, So we discussed like the general idea of detecting ranges with branches. So let's talk about ordering your checks so they don't overlap and nothing becomes unreachable. So use an ordered else if chain from a most uh, specific and highest range down to the default. That way, once a condition matches, the rest won't be evaluated and your ranges won't collide. Like for example, uh, like a speeding limits, like speed greater than 80, that's excessive speeding. Speed greater than 65, that's speeding. uh, that if else within limit, again, higher threshold first. If you check uh, speed greater than 65 first and then greater than 80, never triggers. So yeah, so some of the things to watch out is overlapping conditions. So using, as I mentioned, using greater than or equal to 80 and later greater than or equal to 70 without careful order values 80 plus match both. only the first branch runs, and which might be fine, but make sure it's intentional. And there will be unreachable branches like broader condition plays first, shallow cases that were meant for later and more specific branches. Why does order matter in an else if chain? Because the chain stops at the first match. If a broad condi broad condition appears before a specific one, the specific one never runs. Always put more specific or higher thresholds first and then step down. So yeah, so be precise with inclusive, exclusive, like greater than or equal to, greater than. Test the edges, the numbers right on the boundaries. Use an ordered else if again, else if chain for the uh, strict, strict and highest range down to the default. Avoid overlaps, unreachable code for by planning your ranges first. Write them down on paper if needed. Uh, yeah, you could like an example try later is you could build a grade grade band chain and print results for 59, 60, 89, 90. And you could also write uh, uh, PMI chain in descending order and test with different numbers. And you can also test with flip the order on purpose to see how a wrong order makes a branch unreachable. Uh, so yeah, those are the good examples to start with. And next we have logical operators and ranges with gaps. So we'll make our range checks a bit smarter using logical operators and then handle gaps in ranges. So we'll keep it simple and concrete. So Java gives you three core logical operators: and, or, not. So and is both conditions must be true, or at least one condition is true. Not, it's like true or false. Uh, you'll use these to build compound conditions. The big rule here is group with parentheses, so your intent is clear. Uh, Precedence can trip you up if you rely on memory instead of parentheses. An example is like a teen check. So we want to check if an age is between 13 and 19, inclusive. Conditions could be condition is this could be like age greater than or equal to 13 and age less than or equals to 19. Yes. So here this reads naturally. Age is at between 13 and at most 19. uh, and when it comes to not, so you can also rewrite it as age greater than 13 and uh, not and or age uh, sorry, age less than 13 and age greater than 19, same meaning, whichever reads cleaner. But yeah, there's an example for not. It could be and for for or it's something like this. uh, yeah, so this is yeah, this is similar to the not. So few things to remember is for getting parentheses, yes, and binds tighter than or, but don't rely on that. Add parentheses so the next person and future you can read it instantly. And misreading precedence. So if you mix and or in one line, group the parts you intend to evaluate together. So next is detecting gaps. So detecting ranges with gaps. So sometimes your valid range isn't one solid block. There are gaps. That's when you use or to combine separate ranges. Like for example, kids under 13 gets a discount. So do seniors 65 or older. So that's when you use or a age less than 13 or age greater than or equal to 65. So uh, yeah. And yeah, few things to remember. One thing to remember is using and instead of or for gaps. So age uh, less than 13 and age greater than equal to 65 can never be true. So no number is simultaneously less than 13 and at least 65. So yeah, so few things to try is ask for age, like that we discussed, like the teen, if age is greater than or equal to 13 and age less than or equal to 19. So yeah, you could try that examples and try to print on your IDE or Zybooks. But yeah, use and to say both conditions must hold. Use or to say either one condition is fine. Great for gaps. Use not to flip a condition. Always you group with parentheses. Readability is important. Test the edges, like for 13, 19, for 10, 20, for 65. There. Yeah. So yeah, when you get time, test these, try these in your IDE and see how it works. You'll get a better understanding. uh, Next we have multiple features, detecting multiple features and common branching errors. So uh, we'll look into multiple conditions working together and some of the most common mistakes beginners make when using if statements. So first is detecting multiple features with branches. So far we checked one condition at a time, like if age is greater than or equal to 18 or if score is greater than or equal to 90. Now we'll see how to handle more than one feature at once. So imagine a shipping program where the cost depends on the package size, weight, and whether it's international or not. So if you try to handle all of that in one giant if statement, it it quickly turns into a tangled mess, something like a spaghetti tree of conditions. You have probably seen that before, lines of if, else if, nested if statements stacked over the place, which is hard to read, hard to fix. So instead, combine your checks cleanly with logical operators. For example, large and heavy packages cost more. Use and symbol. uh, International or fragile packages need special handling. That's when you use or symbol. So when your logic gets too heavy, too long to fit comfortably on one screen, or starts to repeat, it's time to move it to into a move it into a helper method. So for example, you could create a method like is international uh, shipping eligible. Yeah, so eligible, that returns a boolean. So then uh, the main logic, let's say f is international uh, shipping uh, eligible. that's much easier to read and easier to reuse. So yeah. So if your if condition starts to feel like a tongue twister, or it's checking three or four things at once, that's your sign to break it into smaller helper methods. It'll make your program cleaner and easier to test. So when uh, and some of the common branching errors. Now let's talk about big like errors, the little syntax mistakes that cause big headaches. Like first thing is assignment versus comparison. So it's one equals instead of two. So like for example, if uh, x equals 5, uh, it tries to assign x to 5 to x, not compare it. So Java will even throw an error or a warning here. Always remember, use compare equals for comparisons, not like you know equals. uh, another another error, common error is the stray semicolon after if. So we have probably seen something like if x greater than 0, uh, uh, greater than positive positive. uh, so the the tiny semicolon after the if ends uh, the statement immediately. So the block runs every single time, even when the condition is false. So that's a classic error. Uh, so another thing is dead or unreachable code. So that happens when a branch conditions can never meet. Like for example, if what's that? Um, let's these. Let's write it like a pseudocode. Else if um, x greater than 20. Now let's say print b. So the second condition, x greater than 20, will never run because anything greater than 20 already matched the first branch. Uh, so that's a dead code. That often a clue you wrote your conditions in a wrong order. Uh, Another example is sometimes like shadow variables. So sometimes you declare a variable inside a branch that has the same name as the as one outside of it, like int total equals 0. Then inside your if you write int total is equal to 5 again. So that new one shadows the first, so the one outside doesn't actually change. It's easy to miss when debugging. So yeah. So combine multiple conditions carefully with and or. Use parentheses to make logic clear. Use your condition when your condition starts getting too long. Make a helper method. Watch for simple small syntax errors like equals, compare equals, stray semicolons, unreachable code. So these small habits will save you hours of debugging later. Try writing a few intentional broken examples this week. You'll remember these mistakes better when you see them happen in your own code. Uh, Now let's see an example, total calculation example. So far we have learned how to write if statements, chain them together, and combine conditions with and or. So now let's put it all into practice with real world style example, which is the toll calculation system. So imagine you're building a software for toll booth. So the toll depends on a few things like the type of vehicle, which is it could be a car, truck, motorcycle, and the time of day, which is rush hour, daytime, nighttime, and the number of passengers to encourage carpooling. That's This means we are making decisions based on multiple factors, exactly what we've been learning. So let's walk through the thought process step by step. You start with the base rate. For example, cars might start at $2. Trucks might start at 3.50 cents. Motorcycles at $1. That's your baseline, and you add adjustments for the time of the day. Maybe during rush hour, say 7 to 9 a.m. or 4 to 6 p.m., the price increases by $1. At night, it could drop to a flat fee of $1, no matter what. So the key is to decide when and how to check these conditions. Usually, you start with the time first because it applies to every vehicle. Then adjust based on the vehicle type, and you can apply carpool or occupancy discounts. If a vehicle has three or more passengers, maybe it gets 25% off. That's the second condition layered on the top of the others. So your code logic in plain English might sound like, if it's night, everyone pays $1. Else, if if it's rush hour, add $1 to the base toll. Then, if there are three or more passengers, apply a 25% discount. So see how we are layering conditions clearly. That's better than one long if line that tries to do everything at once. So few things to remember here is uh, few things go wrongly easily here is inconsistent ordering. So if you check rush hour before checking the night rule, your flat late night fee might never apply. uh, Always handle bigger or overriding rules first, then like the late night rate. And another thing is, you could miss default case. Always end your logic with a clear else or default case. For example, if none of these special conditions match, use the base toll. This avoids uninitialized variables or missing outputs. Um, Make sure your time ranges don't overlap, like rush hour ending at 9 and night starting at 8. So double check that boundaries make sense and don't trigger two rules at once. uh, so yeah, yeah, it's an example. I think it's in your Zai book also, similar example. But yeah, so yeah, let me conclude. So this whole example brings everything together, like multiple conditions, like using logical operators, ordered checks, so only one rule applies at a time, and a final default case to cover everything else. So when you build your own programs, don't jump straight into coding. Start writing the rules out in plain English first. Like, ask what are the inputs, what's the base case, what's exceptions or special conditions exist. So that simple planning step saves you a ton of debugging time later. So yeah, when you get time, try this in your IDE. Start with a base rate and layer in time of day, carpool logic. Once you get that working, you'll be ready for any multi condition challenge that comes next. So the last topic for today is the order of evaluation. So uh, order of evaluation, which parts of condition Java evaluates first, and how parentheses keep your logic honest. So there are two ideas to keep in your head: precedence and short circuit evaluation. So precedence is basically which operators bind tighter, and short circuit evaluation is when Java stops early because it already knows the answer. So precedence you actually need in Java is the and has higher precedence than or. That means A and B. Sorry, A or B and C. Actually, let me write. So A or B uh, and C is read as A uh, A or B and C. Usually you add parenthesis. Uh, so comparison operators like less than, greater than, less than or equals to, greater than or equals to, compare equals, not equals to comes before and uh, and or. So parentheses beat everything. They make your intent explicit and your code readable. And we have left to right with short circuit. So and evaluates left to right and stops early when the left side is false, because false and anything else is false. Or evaluates left to right and stops early when the left side is true, and because true or anything is true. So short circuiting isn't just a performance trick, it's a safety pattern. Like for example, if s not equals let's say null, uh, and s dot length uh, greater than 0, uh, this is safe because the second check runs only if the first is true. And if you flip it, like so if you flip it, um, you risk a crash before you even check for null. So rewrite with parentheses, like take this condition, is member or uh, is student uh, and total um, greater than 50. So because and binds tighter, and Java uh, reads it as like something like this: is member uh, or um, yeah, Java reads us like this. So if what you meant was is member or is student and total, within brackets, total greater than 50, write it as something like is member uh, is student and total greater than 50. So yeah, so same words, different meaning. Parentheses make it undeniable. So try these tiny experiments in your IDE. Print results of true or false and false versus, in parentheses, true or false, and then and false. So with a null, with a variable s is equal to null, test s not equals null and s dot length greater than 0, which is safe. So yeah, try these try different things to see how it works, and you'll get a better understanding. So few things to remember, avoid is assuming wrong precedence. So writing A or B and C and thinking it's parenthesis A or B and C, it's not. So, and forgetting parenthesis. So when mixing and or, even if you know precedence and the next person reading your code may not. Another thing is reversing guard order. So dereferencing before checking for null, axing an index before checking bounds. Short circuit saves you only if you put the guard first. And so mixing and or, add parentheses to show grouping. If you're doing a null or bounds check, put the guard on the left of and. Unsure about precedence, use parentheses, always safe and always clear. Uh, so order of evaluation isn't about being clever. It's about being correct and clear. Parentheses show intent. Short circuit keeps you safe, and a tiny reordering can be the difference between a clean run and a crash. So yeah, try it in your IDE and try these mini tests. Watch how parentheses change the outcome. If something doesn't line up with your expectations, just contact me. I can help. So that's all for today. We'll discuss the next rest of the topics in the next session.